Okay, so here's where we're getting started on our factoring. This is our, like I said, this is where you don't want to miss anything if possible. So today we're dealing with monomials and factoring. Somebody remind me what a monomial is? It's one term, okay? What does one term look like? Give me some examples.
15a squared.
Okay, 15 what?
15a squared.
15a squared is a monomial. Okay, somebody said x plus 1. No, that is a binomial, okay? But if I did x, would that be a monomial?
Yep.
Yes, okay, so those are all monomials, okay? All right, so that was just a brief little thing I wanted to show you there. All right, let me get rid of that. Now, first thing we have on your notes is to find prime factors of 12. If we use our factor tree, like we did yesterday, we have what? 1 and 12, and
Negative 1 and negative
the opposite, negative 1 and negative 12, and 2, 6, negative 2, negative 6, 3, 4, negative 3, negative 4. And then you go back, and the next number would be 4, right? And then they just repeat, so you don't have to do that again. You don't have to go the other direction. Okay? 210 is significantly longer. Okay, so for 210, we obviously have 1 and 210, negative 1 and negative 210, and then what? 2 and 105, and negative 2, negative 105, 3 and 70, negative 3, negative 70, 5 and 42, obviously the opposite, negative 5, negative 42, 6 and 35, the opposite, negative 6, negative 35. Okay, 7 and 30, negative 7, negative 30, 10 and 21, negative 10, negative 21, 14 and 15, and that's always a pleasant sight, because now I know it's going to start over, right? Okay, so that's all of our factors. Now, just to give you a little help, now algebra 1, the factors, prime factoring or factoring like that should be relatively easy. And so you don't generally have to do this. Most of you guys can do this through your head or through your calculator. But if you need to, you're dealing with huge numbers. I want everybody to follow along with me in the calculator. Okay? Everybody hit y equals in your calculator. Make sure it's cleared out under your y equals part. Okay? And then I want you to hit 210 divided by x. And hit second graph. 210 divided by x. Second graph. So you're bringing up a table, right?
Yeah.
What do you see there?
All the numbers that are up there on the board.
Pretty much all the numbers are up there on the board. Now, the one thing about a calculator, especially when they make a table for you, is they're going to have 1 and 210, 2 and whatever, you know, and so forth. But then they're going to have 4 and 52.5. We don't want that, right? They've got to be prime factors. Okay, that means they've got to be numbers that are even number. Whole numbers, not fractions. Okay. So that is a shortcut method to finding your factors, because all I have to do is go down there and pick them out. Yes, sir. Yes, sir. Will do. Bye. Press it. Hold them. Okay, any questions on that? That was just kind of a shortcut. And if you forget, that's no big deal. I won't help you on a test, so don't ask for that on a test. You need to memorize that.
Do we put this 4 point and 52.5?
No, you will not put the fractions. Okay? Well, it's just,
Okay.
you're just way, way down.
Okay.
So, if your calculator is off, generally your calculator will start in that 0 to 1 area. If your calculator's off, and it, like hers is in 341, she can arrow all the way back up to 1, Or the quickest way to get something that's janky off your calculator is just to hit second plus 712. Just master clear it. These are school calculators. Nothing should be programmed on here other than what doesn't come off. Second plus 712. And that'll master clear your calculator. If you're ever having an issue with your calculator and it just seems weird, just do second plus 712. Especially in this class, only because in my geometry class, we'll change the mode every now and then from degree to radian or radian to degree or whatever.
That's what happens when people use my calculator. They
Yep.
forget to put it back.
And it kind of messes you up a little bit. Okay, so here's our next challenge, if you want to call it that. Okay, we are going to factor. Let me change this. So this is example A on your notes there. We're going to factor 15a cubed b squared. Okay, 15a cubed b squared. See if you can do that on your own for just a second. This is what I'm going to do. I want to take it down, and one thing that we didn't do in the first example, let me go back for just a second. One thing I skipped over, it says prime factors. Okay, prime factors are numbers that cannot be divided by another number. Okay, so when I do a prime factor, the way I do a prime factor is I would say, okay, just pick any two factors of 12. Anybody? 2 and 6. Okay, can 2 be factored by anything else? No, it cannot. Can 6 be factored by anything else? Yes, so 6 becomes 3 and 2. So here are my prime factors of 12. 2, 3, and 2. Now, the only thing that this is really good for is when it asks you for prime factors. When we start doing our factoring unit, this is what we want right here. Okay, we want these trees, okay, if you will. If we do 210, let's do 210 the same way. So with 210, pick any two factors.
14 and 15.
Okay, 14 and 15. That's a good choice because those are bigger numbers, right?
Need smaller numbers than like.
Huh? Well, they're two big numbers is what I was getting at, yeah. Or instead of having one small and one big, okay? So then I can factor 15 to
3 and 5.
3 and 5. Can I go any further than that?
No.
No, so that's a prime factor, that's a prime factor. Over here,
7 and 2.
7 and 2. 7 and 2. And there's our prime factors there. 3, 5, 7, and 2. Even if I would have started with 2 and 105, I would have ended up with the same thing. It would have just taken me longer to get through it on 105. Did everybody follow that?
Yeah.
Their prime factors are going to be the same no matter what. Everybody good with that? Okay, using that same idea, let's factor 15 that way. So 15 is
3 and 5.
3 and 5. What is a cubed?
8 times A times A.
A times A times A. And b squared is?
B times B.
B times B. So essentially when we factor something that's a monomial, all we're doing is taking it and putting it in an expanded format. Does everybody follow that? We just took it and expanded it. Again, this is only helpful in the introductory phase. Eventually, you won't do this very often at all. Okay? So let's look at B. We want to factor negative 45 xy squared. Okay? So, negative 45 is?
3 and 15.
Okay, so 9 and 5 is what I heard first. 9 and negative 5. Okay? You factor this now to 3 and 3. Now this negative 5, and depending on the teacher, it's a little different for each teacher, but that negative 5, you're actually going to factor out to what?
5. Negative 1 and 5.
Negative 1 and 5. Okay, to get that negative off there. Does that make sense? Normally I wouldn't factor down to 1 and 5 because that's logical already, but to get that negative out there, I want to get negative 1 and 5.
The negative's still there.
But it's as a negative 1.
Okay.
So all my other factors are positive.
So that's better than just
than having a negative 5, yeah. Okay, so now, with that, it's going to be 3 times 3 times negative 1, which we generally put in the front, but it's okay here. And then what's next? Times x times y times y. Okay? Any questions on that? That's your answer for this, okay? And again, this is a very brief, we won't do this very often kind of deal.
So, when you put the factors in the, what happens like with the 5? Like you just.
With the 5 here,
Yeah.
what happens with it? It's 5.
Oh, never mind.
Because ultimately, we're setting ourselves up to do what? We're going to multiply this, right?
Yeah.
Now, here's one thing I will tell you. When you factor these, okay, when you factor these, you're going to pull them out, and when I multiply them all back together, they should still equal what I took it apart from, right? So I pull it apart. So if I multiply 3 times negative 1 times 5 times x times y, it's going to come out to negative 45xy squared. So that's one way to check yourself. If you aren't sure if it comes out right, go back and re-multiply all those numbers together and make sure they come out with the same answer. Okay? All right, so do C yourself. And that's 7r squared s to the 5th power t.
Do you even have to factor 7?
Nope.
Okay,
Again, some teachers will have you do 1 and 7, but to me that's redundant. Okay? That's a prime number already. This process is called factorization. Okay, it's when we take our factors and show you basically what the factors that we used to create that number was. Okay, so what's our first number, Hammer?
1 and 7.
Okay, 1 and 7, if you want to do it that way, that's fine. What's our next number? R times R. Okay, Savannah, what's next? S times S times. Okay, times 5, and I'm running out of space over here. Got to write smaller. And then I already heard Alexa say at the very end there's just t. So 1 times 7 times r, times r, times s, times s, times s, times s, times s, and then there's just t at the end.
Some great S's right there.
Yeah, it's because it doesn't, when you have a big fat tip like that. Okay? All right. Okay, moving on. So, in your parentheses there, or that, yeah, well, I was reading something else that popped up on my screen. Yes, ma'am. Yes. Okay. Bye.
I heard.
Okay.
Miss Blosky?
No, Miss Holt, and take your stuff with you.
Oh, okay.
Okay, so in the line there, it's talking about the greatest common factor. Okay, so you can go ahead and write that in your line on your notes. The greatest common factor, in parentheses, it's GCF. Okay, you're going to hear that a lot, GCF. Are 2 or more integers is the product of the, okay? So the GCF of 2 or more integers is the product of the factors common to the integers. Okay, so if you're not quite understanding that, let's take a look at example A underneath that where it says 15 and 35. So if we find the GCF of 15 and 35, what we're going to do is we're going to go ahead and break it down. Okay? And we're going to try to find our greatest common factor. That means the biggest common factor, right? Okay? So, again, you can factor this using the factor tree. I'm just not a big fan of that, okay? I'm personally not a big fan of breaking every number down using the factoring tree because of when we get into the factoring unit, it's going to look more like this. So what are the factors of 15?
5 and 3.
Okay, and we're going to skip 1 and 15, okay? So 5 and 3, are there any other factors of that? And we don't need the negatives here because we want the greatest, so that means it needs to be what? Positive if possible, right? Okay, and in fact, we actually don't. Let's go back. I said we're going to skip 15. We're not going to skip 15. 1 and 15, and then 5, and then 3 and 5. Really, if we go in the right order, right? Okay, so 1 and 15, and 3 and 5. Are there any other factors of 15? No. And then on 35, you have 1 and 35. And generally speaking, when you have the bigger number 1 and 35 is going to be irrelevant. We did 1 and 15 because there is a possibility, if we didn't know, there could be a possibility that 15 goes into 35, right? But it doesn't, okay? But 35 is definitely not going to go into 15, okay? So 1 and 35, 5 and 7, and then it starts over again, right? So now what you do to find the greatest common factor is you find the number that they share, that's the biggest. 5. So the greatest common factor, or the GCF, is equal to 5. Very simple. Okay, so you do B. 12, 42, and 96. So what do you have for GCF?
6.
Okay, so several people have 6. So let's check that. If we do 12, we have 1 and 12 because it's the smallest. So we can use 1 and 12. 2 and 6. 3 and 4.
Is it okay to use the shortcut just?
Yeah. I'm just always going to go to the longest process first. 42, I'm not going to do 1 and 42 because I know for a fact 42 is not going to go into 12. But I can do 2 and
21.
21. What else? 3 and 14. What else? 6 and 7. And then it's going to start over. Okay, what about 96? What are my factors of 96? Again, I'm not going to use 1 and 96 because I know 96 won't go in there.
2 and 42.
2 and 43.
3? Yeah.
2 and 48.
Oh, yeah.
Okay. 3 and 32. 4 and 24. 6 and 16. Is that it? 8 and 12. That's it. Okay, now, here's a trick for you. Yes, go ahead.
Okay, couldn't you just stop at 6 and 16?
Just about to say that. Okay? I can, what she was about to say is I can stop, and it's not that I want to stop. I can stop at 6 because 6, not because they all have 6 in common, which is the answer, but I can stop at 6 because here's the deal. After 6 here, there's no number higher than 6. After 6 here, or 7, there's no number higher than that. And so there's no point in getting an 8 and 12. Does that make sense? Okay, now I wouldn't stop until I got to 7 here, but there is no 7. Okay, now I'm going to go through and find which ones they have in common. Well, again, they have 2, right? They have 3. Okay, so that eliminates 2 because 3 is greater than 2, right? Okay, now let's keep looking here. 6. They all have a 6. Okay, 4. They do not all have a 4, right? Because 42 doesn't have a 4. So 4s are out. There's no 5s. We got 6. There's only one 7 on there. So that's out. There's one 8. That's out. No 9, no 10, and so on and so forth, right? So we can clearly see the one that's the highest is 6. And again, we went through an evaluation process that we didn't have to go that deep into the process because you'll be able to see it and spot it more quickly. Okay? This is how I do GCF. There are some teachers who do it differently. There are some teachers who will take it down and they'll factor tree it out, and then they'll have all the prime factors, and then they'll multiply together the prime factors. And this is, in my opinion, better because it'll go directly towards the way we factor here coming up. Okay? If you want to do it the other way, I can talk to you in tutoring about it, or whenever you need help with that. Okay? Alright, so now let's look at the GCF of each set of monomials. Okay? So here's A. This is 27A cubed B. And 15. Oh yeah, sorry. 15AB squared C. And this one's supposed to be squared, not cubed. Okay? Okay, the first thing you want to do is start with 27 and 15. Okay, so 27 and 15. I'm not going to do 1 and 27 because 27 is bigger than 15. Okay, does 2 go into 27? No, so then you have 3 and 9. Is there anything else?
9 and 3.
9 and 3, right? So there's nothing else. Okay, so I'll go over to 15. Now here's a trick for you. If you only have one set of factors, like this, then your only possible GCFs are going to be 3 or 9. So what I would do is I'd say, okay, 9 is my biggest of the two numbers. Does 9 go into 15?
No.
No. So 3 has to be my GCF, and that's 3 and 5 if I want to write out my work. And so now my GCF is at least 3 something. Now remember, it's the greatest common factor, what they have in common. So that's not it. I still have variables I got to deal with. Now, they both have A's, right? So would you conclude that they're going to have A in their common factor? Absolutely. The question is, how many A's? One. Why only 1? Because that one has 2. Because the other one only has 1. In order to be common, they have to have the same, right? Can't have 2. If she doesn't have 2, we don't have it in common because I have 1 more than her. So the greatest common factor for A is A. Okay? What about B? B, because the other one has 2 B's, but the one only has 1 B. Okay? So it's B. There's no C in our greatest common factor. Why? Because it's only on one side. This one does not have a C, therefore it cannot be a greatest common factor. They don't have that in common. Okay? So our GCF for this one is 3AB. Okay? 3AB. GCF is the easiest way to factor. Okay? Just taking out what they have in common. The highest number of the things they have in common. Okay? Let's look at B. Does anybody have any questions? Okay. B is negative 39, x squared, y cubed, and negative 26, x to the y, or xy to the 4th power. Now, what's our greatest common factor?
-13.
Okay? Let's just say,
13.
now hang on one second, because he said negative 13 initially, and now he's kind of changing his tune to 13. It's negative because why? They both have negative, right? If they both have negative, you want to take those both out. Even though it's going to devalue your number, right? Because technically it's going to be a lower number. But if they both have a negative, you take a negative as your greatest common factor. Okay? That's all you got to do. It's just memorization. If you have both of them have a negative, take the negative out. And a lot of times we're going to take the negative out all the time. Okay? We always want to work a positive. It just depends on the situation. I want to try something real quick before you get to... Well, doggone it. Didn't give me an example. A good one. Never mind. Okay. So 13. Negative 13 is our GCF so far. Okay. What's next? Okay. How many X's? 1, because they both have one X in common. Because they have an X. But this one only has 1 to give, right? So think about it like that. Give me the most you can give me that's equal to the other person. Okay, yes?
I'm confused on like the negative.
Yeah, it's just memorization. That's why I was looking at you telling you it's memorization. If you have negatives on both, you got to pull them out. Pull that negative out.
Just like,
You have negative here and here, just pull out the negative. That means this GCF is going to be negative.
oh, okay.
So they're both negative, just pull it out. They're both negative, just pull it out. A lot of times you're going to pull your negative out, and you'll see this later on when we get into our factoring trinomials. You'll pull a negative out to make a number match. Sometimes you'll pull it out, sometimes you'll leave it. Okay, but when they're both negative, you pull it out and make your GCF negative. Yes, I know that this devalues this number, so it's not really the greatest common factor anymore, because technically the greatest common factor would be a positive 13. Okay, but when they both have negatives, you take the negative out. Okay? Okay, so you have one X to share. Okay, but what about Y's?
Y cubed.
Y cubed. So now I have 3 to share, right? Because each of them has 3. Okay, so what I'm really looking at when I'm looking at my GCF, and this is going to kind of blow some of y'all's minds and maybe confuse some of you, but when I'm looking at GCF for my numbers, I'm looking at the biggest number. And if you want to think absolute value, you can, but I'm thinking of the biggest number. When I'm looking at my variables, I'm looking at my smallest common variable, right? Because they share 1x, my small number is coming down. Okay? They share y's, but my small y is coming down. Does everybody follow that? Okay, so it's kind of reversed when you're talking about variables. Okay? I want to give you one more example that's not on your sheet there. Let's say we have negative, let's do negative 24 x squared y to the third and 12x y to the fifth. Now, I want to show you this. Sometimes when we get really good at this, so the next couple days or so, when you get real comfortable with this, sometimes what we do is we get to going fast. And we may say, you know what, my GCF is 6. Let's just say our GCF is 6. Okay? We can take this negative off just to not confuse anybody. So the GCF is 6. Okay? And then my variables are x and y cubed. Everybody agree with x and y cubed? Hold on, I'm going to tell you about the 6. I'm not asking about the 6 right now. Everybody understand the x and y cubed? We're good with that? Okay, now here's the deal. What you want to do is this. When we really get into the factoring mode that's more challenging, okay, the way you can check yourself is give me the answer when you divide this number. So 24 divided by 6 is what? 4. Okay? X squared divided by x is?
X squared divided by x is
X, right?
yeah.
Okay? Y cubed divided by y is?
Y.
Think about this. Y cubed over y cubed.
Oh, 1.
1, it's 1 or there's nothing. Because 4 times 1 is going to be 4, right? So that cancels out essentially. Okay, so that's what's left when I divide my GCF by this number. Okay? Now, let's go over to 12xy to the fifth. 12 divided by 6 is what? 2. X divided by x?
Out.
It's gone, right? X divided by x is 1. 2 times 1 is 2. So that's canceled. Okay? Y to the fifth divided by y cubed is y squared. Now, when you do this, this is a way to check your work. When you do this, when you take your GCF, divide it into your problem, okay, they should have nothing in common anymore. If you have the true GCF, they should have nothing in common. So notice, do 4 and 2 still have something in common?
Yeah.
Yes, they have a 2, right? So the GCF between 4 and 2 is 2. Everybody agree with that? So what you would do now is say, okay, now these GCF is 2. So what I would do is I would take this 2, because it's okay to mess up, and say, all right, I need to take that 2, and I need to do what to this number? Multiply it. So 2 times 6x y to the third is 12x y to the third. See how you fixed yourself? Okay, so you essentially did it wrong, but you were smart enough to check your work, and then you were able to fix yourself. Do you see that? Because a lot of you initially were going, that's 12. 12, not 6, that's 12. And that's how you get that 12 back. And so now if I have to go back up here and divide, that's going to leave me with 2x, and over here it's going to be left with y squared. And now they have nothing in common. 2x and y squared have nothing in common. And that's the goal. When you divide your GCF out of here, it should have nothing left in common. Does everybody understand that? Okay? And a lot of teachers don't teach that, but I want to show you that because there's going to be times when we get going fast and furious on trinomials and stuff that will factor out the wrong GCF. Because some of you guys are limited to 6 and 8 and 10 and 12, but you don't think about 13 and 17 and 18 and 19 being possible GCFs, and that's okay. And so then you can go back and fix it by taking, if you have another GCF, take it and multiply it by the original. Okay? All right, last but not least.
This is the easiest problem.
It says the sides of a 3 triangle are, so I'm going to draw my triangle real quick, because I always like to draw pictures if it tells me about a shape. Okay, so the sides of 3 triangles are 12WZ squared, well, 8WZ, and 16W squared Z. Find the GCF of all 3 sides. Okay? So the GCF, I heard 4 go out real quick. It's got to be more than 4, right? 4WZ. Okay? Now let's verify that. Let's check our answer. 16 divided by 4 is 4. W squared divided by W is W. Z divided by Z is gone, right? Canceled out. Okay? So this is what I have left when I divide that out, when I divide my GCF out. So 12 divided by 4 is 3. W divided by W is out. Z squared divided by Z is Z. So that's what I have left when I divide out my GCF. Okay? 8 divided by 4 is 2. W divided by W is out. Z divided by Z is out. Do any of these 3 numbers have anything in common? No. What? What do they have in common? They all 3 have to have something in common, right? Because 4 and 2 have something in common, but they have to all 3 have something in common. So there's nothing that all 3 has in common. So 4WZ is my GCF of all 3 of those numbers. Everybody follow that? Okay, and that is it for this particular part. And again, this is the easy part.